Welcome to Pocket Ronnie, where we save your mathematical life.
Okay, we're going to be solving for the unknown still. We're solving for x, but we're going to get rid of fractions. Okay, this problem we're solving for the unknown, but we have fractions. There are several different ways you can do this. If you want to work with fractions and keep fractions and make common denominators, that is okay. But I'm going to show you a way to where you can solve this and get rid of fractions. Most people don't want to work with fractions. So you have 3/5 x plus 3/4 equals 1.5. The very first thing I recommend is to change all mixed numbers into an improper fraction. So therefore we'll have 3/5 x plus 3/4 equals, changing this into an improper fraction, 2 times 1 is 2, plus 1 is 3, that would be 3/2. Okay, so now what I want to do is I need to determine the least common multiple. I am trying to determine a number that I can multiply all of these numerators by in order for these denominators to divide into it. Okay, the worst case scenario you can do is you can multiply all three of these numbers together. 5 times 4 is 20. 20 times 2 is 40. If I multiplied this by 40, 5 divides into 40. If I multiply this by 40, 4 divides into 40. If I multiply this by 40, 2 divides into 40. But there is a smaller number. I can use a smaller multiple and I can use 20. If I use 20, you can see that 5, 4, and 2 all divide into 20. The reason I can do this is how I'm doing it. If I multiply this by 20, then I have to just do everything by 20 because that's balancing the equation, it's balancing that seesaw. Whatever I do to one thing, as long as I do it to everything, I am balancing it. So I can make any number a fraction by putting it over 1. So I'm multiplying this by 20 over 1, which means I'm also have to do this one by 20 over 1, and I'm multiplying. So I'm going to use parentheses to show multiplication times 20 over 1. Parentheses shows multiplication. Okay, let me see if I can get my plus sign out of there. Plus. And this is my variable x. Alright, so as long as whatever I do to one fraction, to one term, I do it to every term that is legal. So if I'm multiplying 20 over 1 times 3/5, you can see that I can cancel my 5 and my 20. So if 5 goes into 5 one time and it goes into 20 4 times. Here my 4 will cancel into the 20. If I reduce them both by 4. 4 divides into 4 one time and leaves 5 up there. Here 2 and 20 will cancel, that leaves a 1 here and a 10 here. Now I can just multiply my fractions. Basically here I have my numerator times my numerator, that would be a 12. And 1 times 1 is 1. But I don't have to write it over 1. So I can just write it as 12, and then I still have my x, plus, multiplying your fractions, 5 times 3 is 15, and then 1 times 1 is 1, but I don't have to write it 15 over 1. I don't have to write it 15 over 1, because 15 divided by 1 is 15. Equals, 3 times 10 is 30, and again, the new denominator would be 1, but I don't have to write it over that. So now you can see I now have an equation like we have solved already and with no fractions. So I multiplied by I determined a number that I can multiply every term so that the denominators cancel, and now I do not have any fractions. So now I'll just solve it like I would any other equation. I need to get my letters on one side, my whole numbers on the other side. So I'm going to get rid of my 15. I'm adding 15, so to get rid of it I need to subtract. Because subtracting is the opposite of adding. If I do that to the left side, I have to subtract the right side. So that becomes 0. I have 12x left here. 30 minus 15 is 15. Now I divide my 12 because I need to do the opposite of multiplication. So if I divide 12 by that side, I divide 12 by this side. That becomes 1. I'm left with x equals 15/12. Reduce all fractions when you can. So I can reduce that by 3. That would become 5/4. If you also want to turn that into a mixed number of 1 and 1/4, that is okay as well. So either of these answers, the improper fraction or the mixed number, is acceptable. But always reduce your fraction. So x equals 5/4 or 1 1/4. And we do not have to check these. But you can check it, it's just a little bit more complicated with fractions. Alright, let's go down to 3D16. Let's do this one. Again, my first recommendation is to change all mixed numbers into improper fractions. So here you have 1 1/5. 5 times 1 is 5, plus 1 is 6. So you have 6/5 x plus 7/10 equals, change this into an improper. 2 times 2 is 4, plus 1 is 5. 5/2x. Alright, we want to get rid of our fractions. We want to multiply by a number that all of these will divide into. The worst case scenario, you multiply them all together. 5 times 10 is 50. 50 times 2 is 100. If you multiplied every one of these by 100, you can see that each denominator would divide into 100. But there is something smaller we can use. Okay? We can actually use 20. Actually, we can use 10. So if you multiply each of these by 10, 5 will divide into 10, 10 will divide into 10, and 2 will divide into 10. So if I multiply this by 10, which is 10 over 1, whatever I do to one term, I have to do to every term because that's balancing that equation. So I'm multiplying each of these by 10 over 1. Okay, and now you can see this, if I reduce 5 and 10 by 5, reducing this by 5 leaves a 1 here and leaves a 2 right there. This 10, I can reduce them both by 10, it leaves a 1 in each place. If I reduce both of these by 2, leaves a 1 there and leaves a 5 right there. Now it's just multiplying my fractions, numerator to numerator. 2 times 6, 12. The denominator would be 1, but I don't need to write 12 over 1. 12 divided by 1 is just 12. Don't forget your x, don't forget your variable. Plus 1 times 7, 7. Denominator should be 1, but we don't have to write it that way. We can just write 7. Equals 5 times 5, numerator to numerator, 25. Denominator is just 1, but we don't have to write that, and then don't forget your x. Now it's just a matter of getting x's on one side, whole numbers on the other side. So I'm going to bring my x over here with this one. So I'm going to subtract, right now 25 is being added, so I'm going to subtract it in order for it to go away to 0. If I subtract on the left, I have to subtract on the right. That goes away, so 12 minus 25 will be a negative 13x plus 7. I'm in debt 25, I'm adding 12. I'm still in debt. I'm in debt 13. Over here on the right side, 0. I don't have anything. I put 0, and that's okay. Now I need to get this 7. I need to move the 7 away. So if I'm adding 7, I need to subtract 7 in order for it to go away. But if I subtract 7 on the left, I have to subtract 7 on the right. That goes away, which leaves me a negative 13x. 0 minus 7. If I have nothing, I get into debt 7. I am still in debt. I have to get rid of this negative 13. It's being multiplied to the x, so I do the opposite of multiplication, which is division. If I divide on the left, I have to do the very same thing on the right. A negative divided by a negative is a positive, and 13 divided by 13 is 1. So I'm left with 1x over here. A negative divided by a negative is a positive. Let me move over here. A negative divided by a negative is a positive, and we'll just leave it as 7/13. Always simplify your negatives. A negative divided by a negative is now a positive. I don't have to write the 1. I can just write x equals 7/13. I can't reduce that fraction. It doesn't change into any mixed number, so I'll leave it just like that. Okay, I just want to make a special note about this problem. In algebra, there are so many different ways you can do a problem. Just like I said up here, if you want to make common denominators and work with fractions, you can. I'm just simply working it with a way to get rid of fractions. Looking at this step right here, you don't have to put all your letters on the left side. You can actually move your 12x to the right side with your 25x. You can put letters on the right side and whole numbers on the left. It doesn't really matter. The main thing is you want letters on one side of the equal sign and whole numbers on the other. It doesn't really matter if letters are on the left or the right, as long as they're on the opposite side of the whole numbers.